as George mentioned, my name is Raphael. I did this research as part of a master's dissertation. I just finished in June. It took me about 6 years to finish it while working full time. So a culmination of a lot of work. You can see my co-authors are leaders in their field. A lot of you know many of them. But I tried to tie together something that I had been working with in the field a lot, which is fill material and coal ash. And this is the kind of stuff that is prolific in urban areas, prolific in New York City. And so the research that I'm going to present today, it's on the factors affecting concentrations of carcinogenic, polycyclic, aromatic hydrocarbons, CPHs for short, and selected metals in urban soil in New York City. So without further ado, historic fill materials. Contains coal ash, coal slag, iron slag, concrete brick, asphalt debris. This is the stuff that persists after a lot of the organics have broken down over time. And these are associated with elevated concentrations of heavy metals and PAHs. What you see on the two charts here, the one on the top from the US Geologic Service, when they took samples of coal and combusted them, they found that the concentration of heavy metals was essentially concentrated into the coal ash, in some cases by orders of magnitude. And in samples collected by the New York State Department of Environmental Conservation, in their soil samples, when they looked at the percentage of weight of that sample containing coal ash or slag, you also see significant increases in concentrations of lead and coal PAHs. We also know that landfills comprise of over 20% of the area of New York City just by the nature of our history. It was public health policy to dump our waste across, something like the last 300 years of our existence in colonial, post-colonial times in the ocean, along shorelines and in low-lying areas to get rid of undesirable low-lying land was the thinking at the time. We also seem to have no better place to put it. So fill material is prolific. It's not just limited to these dark shaded areas that you see on the figure here. You find it in just about every soil in some proportion in New York City and in many other areas as well. We also know that some metals are biological toxins and that 7 PAHs are probable human carcinogens. So these are the CPHs. New York State does have soil cleanup objectives that are meant to be protective of public health, but these were based on rural background concentrations, and they're not necessarily representative of urban soils, which are impacted more heavily than rural areas. So the goal of this research was to identify those specific factors that are most strongly associated with concentrations of higher PAHs and metals, and to support a data-driven approach to soil management in urban areas of New York State, like New York City, that's more representative of the conditions that we live in. These are the metals that we looked at in our study. Essentially, it's the metals that we found to be related to the presence of coal and coal ash. And then these are the 7 CPH compounds that we looked at. And when we plot the data into, here's methods. We looked at over 500 sites investigated through the New York City Voluntary Cleanup Program. Thank you to Dan Walsh for helping to create that program. It was all publicly accessible data, so we just tweezed through all those reports. Sites that were investigated between 2010 and 2018. We pulled one sample from each site. In some cases there was 20 or 50 samples collected. Just one sample from each site. We biased towards, towards shallow soil, samples that were collected further away from the roadway, because we wanted to get away from other sources of contamination. I think some of the point of our research was to look at what's the background condition in New York City. We also focused on samples that had coal ash or slag, and we omitted any sample from the data set that had evidence of, let's say, petroleum contamination or some alternate source. Then we did some statistical analysis and plugged it into GIS to look at spatial relationships. And here's what we got. You're looking at the presence of fill material and the distribution of the sites. We found that fill material was present in almost 80% of the locations that we sampled. Our site locations were not randomized. This, again, we pulled together existing data, so we didn't get to choose the locations, but the majority of our sites, sorry, folks, my My cursor is freaking out here. The majority of the sites are in Brooklyn. We only had 7 sites in Staten Island. And then those hatched areas are those historic landfill areas. So we did look to see if there's correlation between the data points and those. Oh, it's freaking out again. The data points and those historic landfills, but we did not find much correlation there. So bear with me, forgive my spazzy slides here, but I'm gonna try and keep it together. All right, and what I'm showing you here is a measure of correlation. Essentially, on the left, you see our target analytes, the metals at top, and the PAHs towards the bottom. And then the column headers are features that we looked at in our data set. If fill material was present, if coal was present, the depth of the sample, and then various features, classes of site use that the site history showed. What we found was that there was a significant correlation between the presence of fill material and increased concentration of our target analytes. Similarly so for coal. These, by the way, are p-values. So a p-value of 0.05 or less is considered significant. So I've highlighted those ones for you. There was a little bit of correlation between depth and arsenic, such that the deeper the sample, the higher concentration of arsenic. Distance to roadway, actually the further from a roadway, the higher the concentration of the highlighted analytes. I'll point out this one specifically for sites that were in current residential use at the time of the investigation. We saw a significant correlation with increased concentrations of lead. Okay, we're going to come back to that. And for commercial use, we saw a significant correlation with most CPHs as well as zinc. So let me flip to the next slide. Now I have trimmed this table down quite a bit just to give you just a few points of comparison. Again, target analytes all the way on the left-hand side. You have our median values in the first column, and then our 95th percentile values in the second column. 95th percentile, I'm not a statistician, I'm just going to try and explain my understanding of it. It's that if you took another sample today, there's a 95% chance that it would be below that value right there. Meaning that this is a very good measure of background condition, or the most conservative measure of background. This is median would be our average background. But when we compare the results of our data set to the New York State residential use soil cleanup objectives, we find that, I've highlighted here, over 50% of our samples exceeded the residential cleanup objectives for the majority of the CPAHs. So most sites are technically not fit for residential use. I mean, I'm kind of overstating that point there, but what I mean to drive home is that most of the soil in New York City that we looked at had substantial impacts, not associated with the particular spill or anything. This is just over the past few hundred years. There are some sources that have led to those increased concentrations. When you compare our data set to New York State's rural soil background 95th percentile values, and again, this is sort of what was used to derive the soil cleanup objectives, you see that our 95th percentile values are, in every case above, in most cases, 1 order of magnitude above, in some cases 2 orders of magnitude above. And when you compare our results to median concentrations of metals that were evaluated as part of a study of New York City community garden soils, our results are actually below that, which was an interesting finding for us, considering that we looked at voluntary cleanup sites that were being investigated or remediated, and the garden study was looking at soil that folks in New York City are planting food in. Gardens had higher concentrations. Alarming, but helped to give us a sense that our data was at least relative. It was within some boundaries of reference data sets for New York City. Here I've put on a chart for you median concentrations of some of our target analytes based on grouping of the features. So here you're looking at total CPH concentrations. All the way on the right-hand side, you see the median value of sites that had coal, ash, or slag present. All the way on the left, for example, then you're seeing median value concentrations of sites that didn't have any fill material. This trend seems to play out. The order of the groupings are all the same across the next 7 charts I'm going to show you. So just hold the places there. But what you see is that sites with coal, ash, or slag had the highest concentrations of CPHs. Only second to residential use sites, sites that were only used for residential purposes or were vacant across their entire history, which was only 30 sites out of our 484, had the second highest median total CPH concentrations. That's high, that's substantial. Industrial sites were even below that. Arsenic concentrations, a slightly different distribution. In this case, sites that didn't have an alternate source present. And what I mean by that is they weren't used as a gas station, they weren't used as a auto repair shop. For whatever reason, this grouping of sites had the highest concentrations of arsenic. Only above, next up there is those residential and vacant use sites. Again, an interesting observation. For the case of chromium, residential sites, again, the highest. For mercury, it was sites with coal, ash, or slag present that had the highest concentrations, median concentrations that is. Next up was industrial sites. Lead, again, you see residential use sites standing out from the crowd. And for zinc, similarly, residential use sites followed by sites that had coal, ash, or slag found. So, just to summarize that, we did see strong correlation between the presence of fill material, coal, ash, or slag, and increased concentrations of our target analytes. The majority of sites exceed residential soil claim objectives for the majority of the CPHs. And then median concentrations of residential sites are among the highest. It's interesting. So what does it all mean, or why? I believe that it's possible that because the residential use sites, a building might not take up the entirety of the lot. You might have some grass areas, some open and exposed soils, but that may act as a sink for aerial deposition, for run-on and some on-site sources. Lead-based paint, for example, outdoor cooking, barbecuing, combustion of organics leads to PAHs. It's also possible that when you have a building present over the entirety of the parcel that it's on, in the case of, let's say, commercial buildings, that it's acting as a barrier, preventing aerial deposition of run-on. Because we saw lower concentrations at commercial sites and industrial sites, even in some cases. So what does this do for us? In my eyes, this presents a framework for urban soil cleanup objectives to be considered. We're not cleaning up every single plot of land in New York City, but I would say that there is an opportunity to do something to protect public health, considering this kind of data. One might be to work with existing programs that have been very successful, such as the Clean Soil Bank that the Mayor's Office of Environmental Remediation put together. Maybe providing something like clean cover soil at residential and recreational sites that are requesting it. Maybe even providing vegetative cover plantings or native plantings for those properties to act as a barrier for some contaminated soil. So I think that's all I got. I wanted to keep it short and sweet and leave plenty of time for discussion. So